Hello everyone. Our topic for today is operator precedence parser. What is an operator precedence parser? This is also a bottom-up parser. Bottom up. And this is basically your shift reduce parser. This operator precedence parser, it takes an operator grammar and it generates a parse tree. Now you may feel that what is this operator grammar? Now, operator grammar, any grammar is said to be an operator grammar if it satisfies these two rules. First rule states that there should not be any epsilon in the right hand side of the production rule. And second rule states that there should not be two adjacent variables together. For example, AB. This should not be there. And if we talk about A plus B, this is an operator grammar. Why this is an operator grammar? Because we have an operator between these two variables. If we talk about this A asterisk B, this is also an operator grammar. If we talk about this A division B, this is also an operator grammar. Now let's take two grammars. Suppose we have a grammar like this: A to E plus E, E asterisk E and ID. Is this an operator grammar? Let's check. E plus E. Let's first match with the first rule. There should not be any epsilon in the right hand side. We do not have any epsilon in this production rule. So first rule satisfied. Now let's move to second rule. Second rule states that no adjacent variables together. Now let's check. E plus E, no adjacent variables. E asterisk E, no adjacent variables. So this grammar, this is an operator grammar. Let's move to the second question. E2, EAE and ID, and A2 plus and asterisk. Now some of you may feel that this is not an operator grammar, but let me tell you, this is an operator grammar. Why? Because the first production rule, E2, EAE and ID, this can be modified like this: E2, EAE. This is the grammar, na? So, but we have another production rule, A2 plus and asterisk. If we substitute this A with these two production rules, then we'll get E2, E plus E, or we may get E2, E asterisk E. So this is also an operator grammar. Clear? Now let's move to the question. The question may be like this: what is operator precedence parser? What is operator grammar? And with the help of the given grammar, parse the input string ID plus ID asterisk ID. Now what we have to do? We have to perform operator precedence parsing. And to do this, we have 4 steps. The first step is to check whether the given grammar is operator precedence grammar or not. Second is to create an operator precedence relation table. Third is to parse the given string. Parse the given string. And fourth, that means the final step, is to generate the parse tree. So to perform operator precedence parsing, we have these 4 steps. Check whether the grammar is operator precedence or not. Second, operator precedence relation table is to be created. Third, we have to parse the string, and final step is to generate the parse tree. Now let's move to step 1. Check whether the given grammar is operator precedence grammar or not. The given grammar is T2, T plus T, T asterisk T and ID. Now, is this an operator precedence grammar? Yes, this is an operator precedence grammar. Why? Because it is satisfying these two rules. There is no epsilon in the right hand side and no two adjacent variables are together. So, yes, this is an operator precedence grammar. Now, second step is to create the operator precedence relation table. Now how to create the operator precedence relation table? What we will do, from this grammar, from the given grammar, we will write the terminal symbols like this, ID, and always remember that whatever the string is given to you in the question, you have to add a dollar mark, and this dollar mark, this end marker, this is also a terminal symbol. So this will be the last terminal. In the same way, write here plus asterisk ID and dollar. Now what we have to do, we have to create the operator precedence relation table. Operator precedence relation table means the table that will determine the relation. What relation? Precedence relation between the operators. Operators, these are the operators. Now, as I told you in the last video, what is the precedence rule? The precedence rule states that identifiers like this, these are of highest priority, and dollar is of least priority. Fine. And then we know that division, asterisk, addition, subtraction. Now there is one more rule in this. If we have two same symbols together like asterisk and asterisk, then the precedence of this left asterisk will be more as compared to the right asterisk. And in the same way, we have, if we have to compare 2 plus together, then the priority of the precedence, you can say, the precedence of this left plus or left addition symbol is more as compared to the right one, and in case of minus also. Fine. One more thing, if we have $2 and we are comparing these two dollar symbols together, then we'll write A. A means except. This is the last step, or you can say this is the terminating step. Clear? Now let's create this table. Plus and plus, same operators, so we'll give left symbol more priority. Now plus and asterisk, asterisk has more precedence. Plus ID, obviously identifier, and dollar and plus, plus is of higher priority as compared to dollar. In the same way, complete this table. Asterisk plus, asterisk asterisk, asterisk ID, asterisk dollar. ID and plus, obviously identifier, identifier, two identifiers together, that means left को ज़्यादा priority देंगे. Now ID and dollar, we know dollar has the least priority, so obviously identifier. Now dollar and addition, obviously addition. Dollar and asterisk, asterisk. Dollar and ID, ID. Dollar and dollar, except. Done? We are done with step 2. Now let's move to step 3. And what is step 3? Step 3 says we have to parse the given string. Parse the given string. Now what we have to do? We have to create a table, and this table will have 4 columns: stack, relation, input, and a comment. Input will always contain the given input string ID plus ID asterisk ID. This is the given string and $1 mark. Stack, initially stack will contain a dollar symbol as the top of the stack element. Relation, for this we have created this table, operator precedence relation table. And last is comment. Comment means whether we are applying a shift action or we are taking a reduce action. I hope you know what is shift action and what is reduce action, because I have already explained these two actions in my last video. Now let's start with this. We have dollar in the stack and relation, input, ID plus ID asterisk ID, and comment. Now let's start. Compare. What is in the top of the stack? Dollar. And what is the first symbol in the input string? ID. Compare the priorities, dollar and ID. Dollar and ID, if we look at this table, where is dollar? Dollar and ID. So we have a symbol like this. Fine. I told you yesterday that in case we have a symbol like this, then we have to perform a shift action. And if we have a symbol like this, then we have to perform a reduce action. So let's move ahead. This type of symbol, that means we have to shift. What we have to shift? The first symbol from the input string. What is the first symbol? ID. That means in the second step, the stack will contain dollar and ID. And here we are left with plus ID asterisk ID dollar. Now compare ID plus ID and plus ID plus which symbol? This one. So we'll put a symbol like this, and we know that in this kind of symbol we have to perform reduce operation. So reduce, and what we have to reduce? We have to reduce this ID. Now let's check whether there is any production rule to reduce ID. Yes, we have T2 ID. So we'll use the production rule T2 ID. That means we'll substitute the value of ID with T. Now we are left with plus ID asterisk ID dollar. Now top of the stack, T. T is a non-terminal. I told you in the last video that we cannot compare non-terminal symbols with terminal symbols. So instead of T, we'll compare this dollar and plus. Dollar and plus, which symbol? Let's take a look at this table. Dollar and plus this. So we'll put a symbol like this, and this means shift. Shift what? Plus. So we'll get dollar T plus, and here we are left with ID asterisk ID dollar. And in the same way we have to complete this table. Compare plus ID, highest priority ID, that means shift. Shift what? ID. So we'll get dollar T plus ID, and here asterisk ID dollar. Now compare ID and asterisk. Obviously identifier has the higher priority. You can check from the operator precedence relation table. Now this symbol means we have to reduce. We have to reduce what? Top of the stack. Top of the stack means ID, and ID can be reduced by this production rule. So we will substitute ID by T. Now we are left with asterisk ID dollar. Clear? Now compare T. We cannot compare, but we have this plus. So compare plus and asterisk. Higher priority, obviously asterisk. So shift action. Shift asterisk. Now in the stack we have T plus T and asterisk. Here we are left with ID and dollar. Fine. Now compare asterisk and ID. Obviously identifier has a higher priority. So the action will be to shift. Shift what? ID. So dollar T plus T asterisk ID. Now here we are left with only dollar symbol. Now dollar, compare. We can ID and dollar. Which one has a higher priority? Identifier. So this means reduce action. Reduce ID by T. So in the stack substitute ID with T. Now we are left with dollar. Now top of the stack T, but this is a non-terminal. We cannot compare. Come to next, that is asterisk. Asterisk and dollar. Higher priority asterisk. That means we have to perform the reduce action. But now here we do not have any input symbol. So what we'll do? We'll check the given grammar. T asterisk T. this can be substituted by t. So what we'll do? We'll substitute this t asterisk t by t. So reduce t asterisk t by t. We are using this production rule and we have mentioned it here in the comment section. Now in the stack t plus this we have substituted with t. So we are left with only t plus t, and here we have dollar. Now again compare. Non-terminal we cannot compare. Plus, yes we can compare. Plus and dollar. Priority obviously plus. So reduce action again. So reduce what? T plus t. Again check the given grammar. T plus t. This can be substituted by t. So we'll reduce t plus t by t by using this production rule. So that means we are left with t, and here we are left with dollar. Clear? Now t non-terminal dollar. Compare dollar with dollar. I told you that if we have a situation like this, that we are comparing a dollar with a dollar, then the symbol will be A. A means except. So dollar compare with dollar will get except, and except means parsing is successful. Done? Now step 4. What is the step 4? To generate the parse tree. And since we know that this is an operator precedence parser, operator precedence parser is a bottom up parser. So we'll start with the bottom. In the bottom we have t. We have to generate the parse tree. Now t is substituted by t plus t. T plus t. This t plus t. T asterisk t. T asterisk t. Now this t is substituted by id. In upper steps this t is also substituted by id, and this is also substituted by id. So we are getting id plus id asterisk id. So this is the final step and we are done with the parsing. Thank you.